Yeah. I would like to introduce myself, first of all. My name is Miguel, and I also work for Dockyard and Chantal. We're a web agency mostly based in the US, although we work all over the place. I live in Spain. And I couldn't fit everything I wanted in this talk, so feel free to just ping me after the talk or contact me on Twitter or GitHub if you want more information. This is a pretty deep topic, just going to scratch the surface of it. So I'm pretty sure you will have questions, and I will try to answer that to the best of my knowledge. This is a talk about offline applications. I guess we have all heard of progressive web apps, and we think we're great. They load fast, they work offline for the most part, and they can be added to the home screen if you add the right manifest to the application. And we at Dockyard, we also build PWAs. We have, over the years, advocated for its advantages for our clients because they are very often a good solution, even a low-cost solution for a native application that very often people don't need. And one of the main technologies powering progressive web applications, it's well known by most of you, and that is service workers. Service workers have been covered extensively over the last couple of years. Even if this very same conference in Amsterdam and Berlin, there was a few talks about service workers. This is not a talk about service workers, by the way. By now, I think service workers are mostly a solved problem in Ember. There are usually like 3 commands away. You install Ember Service Worker, then you install Ember Service Worker Index, and then you install Ember Service Worker Asset Cache. And for the most part, you have an offline application. That's it. We can all go. We can all go have beers and whatever. That's everything you have to know about offline applications. No. If you're an Ember conference, chances are you are building things with Ember. And if you are doing that, chances are your application is a bit more complicated than the kind of landing page that is well served with the commands we saw before. Your application is probably going to read from an API of some sort. It's going to save data. It's going to send data to the server, maybe to several services. And that's not what Service Worker is designed for. Service Worker is very good about caching assets and things that don't change very often, because we can just generate a fingerprint on assets, and we know if things have changed. But that's not the case with APIs. If you're using github.com/API/repositories, you're going to get a list, and if you call the same thing 5 minutes on, it will get you a different list. Things are ever changing. So we need something else, some other tool that allows us to do what is called offline data management. That is the next step on going towards a fully offline experience. And offline data management is nothing else than the ability to query and update your application's data, even if the server is not responding or is misbehaving in any way. And that's, like I mentioned, is not something service workers are good for. We need something else, some other library to have us advance and act as a caching layer on top of our data. And I want to introduce to Orbit, which is what drives the pun on the title of the talk. Orbit.js is a library created by Dan Gebhardt, also a member of the Ember core team. But it's not specific to Ember anyway. In fact, most of what I'm going to talk in this presentation is not Ember specific. And really nothing is Ember specific in here. You can use the same things I'm going to talk about in React applications, Vue applications, or Svelte applications, anything. I want to also start with a disclaimer that unlike service workers, designing for fully offline application, it's a bit more complicated and nuanced than running 3 commands on the command line. It's not so easy to retrofit on an application. Not to say that it's not possible, but if you are lucky enough to be on the beginning of a project and you know that offline is something that could be valuable for your users, much like testing or accessibility, Adding it as an afterthought, it's going to be much more work, and it's usually going to be more complicated to reach a state where you're happy with the result. And now let's go to the good news. You have been, all of you as a team, you have been hired by the European Space Agency, and you're going to write software for a nice project they have. The European Space Agency is sending the first inhabited space station that is going to orbit the moon. Why the moon and not Mars? Because it's a European space station. It's not the NASA. You know, they don't have the budget. So I want to thank my wife for all the awesome drawings you're going to see. They're all her doing. And one of the very interesting experiments they're going to run on that space station is that astronauts are going to grow their own food. That is a nice experiment to just prepare for interplanetary travels. So they're going to just observe how plants react to different kind of, watering, fertilizers, amounts of light, and whatnot. And I'm going to live code it. Yeah. The second I had this idea, I thought it was good. Yesterday, not yesterday, like last week, I said, why? And another speaker mentioned that they gave her talk to her dog. I did the same. At the beginning, she seemed pretty interested. By the end, not so much. She's not a good talker, a good listener, I think. But either way, you may think that I have prepared this a lot. I did not, so terrible things may happen. Let's go to the live coding session. I'm going to show you your application, and I'm going to make everything a bit bigger. And also this. Maybe that less. OK. They're going to grow three kind of... Oops, this is moving. They're going to grow three kind of crops on the space station: potatoes, tomatoes, and beans. So the purpose of the application is that they can enter the crops and specific plants they're tracking and sending the information to wherever the European Space Agency headquarters are. Nobody knows. And so a team of biologists can going to give advice about, oh, it needs more water, or it needs more fertilizer, and things like that. So this application, so far, is empty. You can add new crops of potatoes, new crops of tomatoes. You can delete them. You can go to the potatoes you created and say, oh, OK, this is around 100 centimeters, because we use proper units in Europe. And it looks in good shape. It's giving us 120 grams of tomatoes per day on average. This one, it's, I don't know, 120 centimeters. And it's looking outstanding, and it gives us a lot of food. And in here, on the other side of the road, scientists on Earth will give you, OK, now increase the amount of water, increase the percentage of the lights you have on them, and things like that. But I'm going to reload, and it's all gone. Right now, this application has no server, no data sources, nothing. Everything is kept in memory. So first of all, I guess the first step is to go and add a data source. Orbit has two main concepts to it. One of them is data sources, and the other one is data strategies. Orbit is much like Ember data, but in the sense that it fills the same purpose, but it's structured in a very different way. So it has no opinions about how your data is propagated around your application. It will become clear with a few explanations. So for now, let's create a data source named remote is going to symbolize our server. That's a convention. It doesn't have to be named remote, but it can be. So EG stands for Ember generate, data source, and we're going to name it remote. And it has to speak with a JSON API. So I'm going to say from, and it's going to see orbit JSON API. And that's going to generate our data source. Then we're going to generate a couple of strategies. Strategies are the way that Orbit has to say, observe this source, observe the events that happen on this source, and react to them doing anything, really. Very often calling another method or another source or propagate the data from one to the other. So we want to synchronize data from our remote source to the memory store, which is where data that we read and write from JavaScript is. And we also want to be able to hook into when we query the in-memory store and when we update our in-memory store. Because when we query our memory store, we want to translate that query to the remote store, which is in turn going to fetch that on the server. So Ember G, data strategy, oops. See, strategy, and it's going to be named remote store sync. The next one is AG data strategy, and this is the one for querying, so it's going to be a store before query, remote query. And the last one is EG, data strategy, store before update, remote update. The convention is that this one here is the one we are listening. This is the event we're listening. This is the one we are targeting, and this is the event, sorry, the action we're calling in it. Let's see how this looks like. I'm going to make this thing bigger. So we have our source, remote source. It's pretty simple. In this case, it inherits from Orbit JSON API. You pass a few injections, and then you read a new source class with injections. That's the way it's defined. I'm using Ember Orbit, which is a small wrapper around Orbit, but again, Orbit is usable in any framework. And then we have the remote query. This is a bit bigger, but at the end, the key parts are it has a source, it's listening for one event, and on a target, is calling the action query with the same events we are receiving. And the same one for this one. It's on the source store when before update. On the remote source, we're going to call the update action. So with this alone, let's see how our application behaves. So I may have to reload a few times because, OK. And that's it. This data is now coming from a server, and if we check the network, you will see, let me clear it, and I'm going to go to beans, or tomatoes, or crops, and every time I make a request, requests are being sent and data is coming in. And if I create a new crop, a new post request is being sent, and if I delete what I just created, I'm sending just delete request. And now if I refresh, it's working well. So far, we have more or less replaced Ember data in the sense that we have the kind of application we're usually building when we are fully relying on the network. OK, it's nice. Let's keep the presentation. So as I mentioned, when we get a query on the store, a before query event is fired, and the strategy is listening for that event and calling the query action the remote source, which is in turn fetching into the server. The same happens when we update record, it triggers a before update event, and the strategy, which is listening to that, calls the update action the remote store, which happens to know how to make a request to the API. And the other way around, when you get a response, this is trigger a transform event, and the sync strategy is listening for that transform event and calling the sync action to the store, effectively making you aware that change happened on the server and you get a response. But we are forgetting something. This is not the kind of application you usually ship, and it's going to run on mobile devices or laptops or tablets, whatever. This is going to run on a computer that is going to be on the space station orbiting the moon. We often forget how far away the moon is. It depends on the time of the year. It also has an 18-year cycle where it's moving, and it's not always orbiting in the same direction. It orbits, the direction of the orbitation varies and changes, but it's roughly around 400,000 kilometers away. That is a lot of distance for the signal to travel. Even at light speed, it's going to take like around 1.5 seconds for the signal to arrive Earth. And chances are it's not going to arrive right into the antennas in the headquarters. I mean, the Earth is spinning at the end. So it's going to maybe end up in an antenna in Sydney, and from Sydney it's going to be rerouted to the headquarters, wherever they are, and then we're going to process the request and send the request back, and it's going to go through with the antenna through to the moon again. In the best case scenario, we're talking about 5 seconds of latency, or 6 seconds of latency. If you want to check how that feels, let's see how that feels. Here you can select moon latency. And let's see how it works. I am on tomatoes. Sorry, I am on potatoes. Let's go to tomatoes. It broke. It broke. 5 seconds is the most that Orbit.js is going to wait for you unless you make it wait for longer. Because if something takes 5 seconds, your server is probably not responding anyway. So to change that, we go to remote and we do injections. Default, I think it's default, fetch settings, oops, and it's an object with time out, 10 seconds, that should be enough. I may have to just go back online so I can refresh faster. Otherwise, I don't want to bore you too much. And I go back to moon latency. And from potatoes to tomatoes, done. And go to beans, and then to potatoes, and then to beans again. Yeah. It's pretty bad. I mean, we cannot ship this thing. I mean, we cannot expect astronauts to use this thing that it takes 6 seconds every time they want to do anything, or create a new crop, or delete a crop, or anything. So, see, it just updated. So, what we are doing here is what is usually referred to as a pessimistic UI. That is, we send a request, and we wait for the response before continue doing stuff. Because we're pessimistic, things may fail. To make Orbit strategies, like the remote, these strategies we define, to not be pessimistic, you have to say blocking false. And the same for the update one. And now, they are not, I'm going to go back to online and refresh. Now they are not pessimistic, so that means requests. If I visit all the requests, all the potatoes, tomatoes, and beans, and whatever, and I go back to moon latency, I was already in beans. Okay, this is, I think I have a previous version cache or something. Sorry, not offline, online. Just in case, just going to refresh one more time. Okay, now it's transitioning immediately to the other pages, even if the request hasn't finished. But when requests come in, we see the result. So we're kind of in a state where, yeah, we're not waiting, but if you don't show any data, and I still have to wait 5 seconds to see data, we're not any better. So we need to add a caching layer. That is where it gets really, really offline. The most common case for this is we are going to define a database in IndexedDB where we store all the data we know of, So the next time we just trust our cache while we get the actual response from the server. For the most part, this is usually okay. Depends on the use case of our application. This can get very hairy sometimes. But for the most part, it's okay to display all data while you get the new one, because data, again, depends on the application, doesn't change drastically from since the last time you use it. So we're going to continue writing sources. And in this case, we're going to create a source from IndexedDB. So e.g. data source, and in this case is going to be going to call it backup, and it's going to be from orbit IndexedDB, and we're going to generate a strategy to sync data from our in-memory store to this cache IndexedDB. So e.g. data strategy, and it's going to be called, I'm going to call it store backup sync. Store backup sync. We're going to sync from the store to the backup. And we're also going to generate another thing called packet. I'll come back to that in a minute. So e.g. data, data bucket main. That should be enough. And enough with moon latency for now. Let's refresh a few times. There. And I visited all the pages. And now if I go with moon latency, I go to tomatoes and potatoes and beans. And requests are still going. If you check this, the first one, they didn't finish. I go to potatoes again, and the request is there. But I'm transitioning right away. And I saw the same data I saw the last time. So I am already being, or we have something that astronauts could use. Like, OK, these are your crops. From the crops we know of. I mean, chances are, unless this is using several computers inside the same station, your data is going to be updated. And if they have several laptops and one of them is creating crops and the other one is also creating crops, they're going to see the crops they don't know of. And a few seconds later, a new crop will pop up because it comes from the API. So that's good. We have an application that can be used offline, even if the latency is awful and the speed of the connection is pretty bad. We can create crops, delete crops, and even if things are, if things are being pretty slow, the application works. So yeah, this is what we call optimist UI. But we all know what happens to overly optimist people. We have an account for something, and it's I mentioned that this space station is orbiting what is called the low lunar orbit. It's an orbit that is around 160 miles over the moon. And given that it's orbiting, it's not always going to be facing Earth. There is something in the moon interesting, that is, the moon is always showing us the same face. And there is the face of the moon that we never see, is also referred to as the dark side of the moon. When the space station is orbiting through the dark side of the moon, it has no direct line of sight with Earth. So there is no way for them to send us any information because it has to be a straight light. And this is not an extraordinary situation. This happens for around 50 minutes every 2 hours. So we're talking about like 45% of the time. So 45% of the time we have no connection whatsoever. So we need to do something for this. And okay, this is out of order, but it's the same thing. This is how we're propagating data to the backup. So we need to do something else in here, and it's account for failure. We have an account for what happens when things go wrong, either because the server fails, or because we have no connection whatsoever. So let's simulate our server failing. We are going to stop this Rails server, and I'm going to put error mode 1. It's a key I have, so whenever I have this flag, it's going to return a 400 no matter what I send. And let's use this. And let's clear this thing, and I call tomatoes. Oh, for this specific thing, I don't need latency. It fails, and now I'm going to beans and potatoes, and nothing is being sent. See, there is no extra request, because Orbit, as soon as something fails, stop processing any further request until you tell Orbit what to do with the one that failed. So we need to rescue from these operations and tell Orbit what to do, so it can keep processing incoming requests. So for that, we're going to create two strategies. One of them is for handling failure while querying, and the other is for handling failure while updating. So e.g. data strategy, and I'm going to call it, I have my notes in here because, you know, I'm brave and not stupid. So one of them is the remote query fail. And I'm going here, and now we have remote query fail. And when the source remote triggers a query failed event, we may want to do something. That's the action, and that's the target. In this case, we don't need the target because we're not going to do anything on another data source. But we do want to do something when this happens. So we're going to just tell this dot source, that is the remote source, request queue. Skip. Because at the end, if you are making a query request and it fails, bad luck. I mean, try again later. We don't have connection, or the server is down, but carry on. So with that alone, if I refresh, it's failing. But if I click on another, I may have to refresh it one more time. So it keeps working. And at some point, we will. Yeah. At some point, we will. One of them will succeed. And the other one, it's for saving data. So I'm going to create a new one. And in this case, in the query fail is date fail. And this is somewhat similar. There it is. When we get a update fail on no target, we don't need target either, on the remote source, we're going to do something. And what we do, it depends on the kind of failure. This is where failure handling is what is actually interesting and challenging of this problem. I had a lot of fun doing a project for a client, where an application was going to be used in the middle of the jungle or in the middle of the desert, and it had to keep working. So in here, there are two kinds of errors. One of them is the server sends us an error, like a proper 400 or 500, or we get an error because there is no connection at all. So if this action receives a transform, we don't care about now, and an error. And if we do, if the error has a response, that means it's we get a response, but it's just a failure response. So console.debug, another one, and it's you know, server responded with E. And the other one, the other option, it's server did not respond. And we need to make a distinction between those situations. If I'm going to handle only this situation where you are offline, in here you also want to this dot request queue. Sorry, this dot source dot request queue dot skip. Like you try to do something offline, just I mean there is several approaches you can go here, but if the server did not respond, you are going to skip this thing. Like I mean, continue processing, and if it's a proper error from the server, we're going to stop. And I guess I'm going to leave that as an exercise for the reader. There are many ways you can go depending on the kind of error. You may want to handle 422 in a different way than 403s, and so on. I will mention that later. So if we back to the application, and I'm also going to make the server work properly for a moment. Okay, let's go offline. We change from tomatoes to potatoes, and it's all being, I mean, all requests are failing. But if now I go online and I refresh, it's all good, and the same thing goes for create requests. Sorry, I go offline, create another one, it fails, I go online. See, when I go back online, it sent the request that sorry, this is the filter. It's the other way around in this case. So, yeah, we could go either way in this case. So I go back online. If something fails because the server wasn't responding because we were offline, like create a new crop, it fails. We go back online, refresh. Now there is a 401 request. That I put it on the wrong order. It's not the request to the request that failed. The one that failed because you don't have connection, the one you want to skip, is the one that failed because of the server. That is where you may want to do something different. If something failed because you were offline, you want to keep it around and replay it later, which is exactly what is happening. If now while offline, I move around, go to beans, go to tomatoes, delete this, and create this, and go back online and refresh. Boom, boom, boom. Many things are going. And it's being sent. There is an improvement to this because when something fails, I stop processing things. I stop completely. And then the next time I enter the application, if there is a connection, I try to replay everything I couldn't replay before. This is where the bucket came to. I mentioned before that I created a bucket. Data bucket is a log of the operations that are in transit. And as soon as they are completed, they are removed from this log. So and this log is stored in DexDB. So whenever you load the application, you check, OK, is there something I couldn't do before? Oh, yeah, there's 3 operations I couldn't do before. OK, let's try it now. OK, they did work. I clear the log, and I'm free to go because everything I tried to do, it's now done. And a nice improvement to this, it's I'm going to open. I have a network service. This is pretty nice, and it's super simple to do. This, at the end, it's just checking for the on-change event listener on the navigator connection thing, the tradition window. And it has an on-change function where you can register callbacks. And in the application route, you're booting Orbit. No, I mean, this is something that it's in the guides. I didn't invent anything. This is on the documentation. You copy, paste, done. And retry when back online. I check the network service, and when there is an on-change event, I receive the new network status. And if it's true, I mean it's online, I get the remote data source, and I ask it to retry. So, we're orbiting the dark side of the moon. There is no connection, so we are offline. And I am, deleting crops, and I'm updating this to be 100 centimeters. This is looking great, and it's generating 200 grams of food every day, and I create 2 new crops, and I go back online. And I should have reloaded one more time. I create 2 new crops. I'm online. Clear. I delete, and then I go back online, and there you go. And it works for any kind of, I'm going to delete 2, going back online. I'm going to delete this, and I'm going to say that this is, again, 1 meter. I'm going to create more beans because I like beans, and I go back online, boom, all of them. There's much more to this. This is a pretty extensive topic. There are many things that I couldn't fit on the talk. Mainly, and this is something you can ask me later, how to handle and avoid validation errors. Because what do you do when you find out that something was wrong an hour later? Many of those problems are difficult, not because the technology makes it difficult, it's because you need to sit down with design and come up with a solution. Like, after you left a form, how do you communicate to the user that something that you did half an hour ago was wrong? Maybe you need to open a model, like syncing changes. Oh, syncing changes fail. Do you want to review your changes? This was wrong. Do you want to change it and submit it again? Yes. But this is a whole, a problem that involves everyone on an application. This also has a nice side effect. How many of you have problems because, suddenly something goes wrong and your server is down? This also helps with that situation where you have a browser that is misbehaving, the application is misbehaving because the server is down. With this, if the server is returning 500, you could say, probably this is my fault, so I'm going to keep this and try later. And for the most part, people won't lose data and will continue to use the application as normal while the server, you're trying to fix whatever fire you have. Data conflicts. It gets interesting while you have several people working on the same data set on different computers. And one of them is working, and the other one is offline. So you try to send something, it is offline. Someone else picks another computer, makes changes, that person is online. So your changes that didn't send the first time, now you try to send them, and someone else came in before. What do? Okay, you can discard your local changes and keep the changes in the server. Maybe you want to go around, you want to smash the server. Maybe you want to ask the user what they want to do. Maybe you do a merge. This is like Git. So it's interesting. And there is another area of this that deserves its own probably conference even, that is designing for these kind of patterns. It involves a lot of people, like how do you make the user aware of the status of the connection? Maybe you have to put a connection icon somewhere, or let them know that they have unsynced changes, or let them know that you are syncing changes that you did before. This is a whole new topic. But now you know the rules. Orbit is pretty simple in that regard. It has a very simple primitives, and you can play with them and decide what the right solution for you is. It has no preconceptions about what the right or recipes about what the right solution is. So you can decide that you want to react in one way to this kind of error and another way to this kind of error, and craft the best UI for your application. And that's it. I hope that I encourage you to try this kind of patterns, because it has been very, very fun to create applications that can run in the jungle, and eventually when they get a hotspot, they sync. It has been a fun ride.